Now, I want to solve part 2 of projectile motion question under theoretical background of projectile. I want to look at some theoretical questions that have to do with projectile. He said, well, this one said, which of the following is the equation of the latus rectum of a parabola of a body launched obliquely into what? Space with initial velocity u at an angle theta to the horizontal. A says minus 2u cos square theta over 2g. B says minus 2u square cos square theta over 2g. C says minus 2u square cos theta over g rather. Then D says minus 2u square cos square theta over g. The options are very close. Now, E is none of the above. Now, for a projectile launched into the space, undergo a what? Form a parabolic shape. And whose formula is what? Is this? Look at the board. Minus 2u square cos square theta over what? Over g. This is latus rectum. Then y minus ym. Your ym is the maximum height, while your xm is what? This is square is what? Range at maximum height. So the answer to the question is what? Option D. Now let's go to number 2. Number 2 says what? In physics, we cannot analyze projectile motion as dash. Option A is a combination of horizontal motion with constant velocity and vertical motion with constant acceleration. Yes. Now, there are in physics of what? Studying projectile, we understand that, or in the analysis of projectile, we understand that projectile consists of 2 independent motions. What does that mean? You cannot analyze 2 types of motions together. And what are the 2 motions that we cannot analyze together? Number 1 is that the horizontal motion with constant velocity and 0 acceleration. Then we have a second one is vertical motion with varying velocity and what? Constant acceleration. The first one I said what? Constant velocity, uniform horizontal velocity with constant velocity and 0 acceleration. That's first one. Second one says vertical motion with what? Varying velocity uniformly and constant acceleration. These are 2 what? Independent motion. If you want to study physics of projectile motion, you cannot combine them to study them together. They are independent motion, and that's why we call it a projectile motion. Is a motion of a body launched into the space of a 2-dimensional independent motion that is under the influence of airward gravity or gravitational acceleration. But most of the times air resistance is also involved, but sometimes we neglect them. So that is just that. So it's the type of motion that is what? Studied what? But not combined. It's studied 2 independent motion. So that's why they said in physics we cannot analyze projectile motion as combination of horizontal motion with constant velocity, yes, and vertical motion with constant. This one is correct. Now, combination of horizontal motion with varying velocity, no. Horizontal motion cannot have a varying changing velocity. Vertical motion will vary, no. You can only vary acceleration for vertical motion, varying velocity. Number option C is a combination of horizontal motion with varying velocity, and no. So the answer is A. Now, the last third question, he said, which of the following is not a type of motion? It's not. A is what? Translational motion. Yes, translational motion is motion of a body that what? That is observed when there's a change of what? Position of a body. It can be along the straight line, it can be along the curve. So we have rotational motion. Rotational motion is motion of a body in a what? Around a circular path without a constant speed. Then we have projectile motion is motion of what? That is studied under mechanism. Basically under mechanism. That has to do with 2-dimensional motion in which the motions are studied independently. So study vertical motion, study horizontal motion of what? Of that mechanism or analysis. So projectile motion is also classified as type of motion. Basically. So I know some people will say, projectile motion, have not heard about it. Yes, is not when they discuss type of motion, we say random motion, projectile motion, translational motion, oscillatory motion. But what about projectile motion? I've not heard. You have heard about it. It's a type of motion. But this type of motion is what has to do with what projectile motion of the body launched into the space under two dimension with the influence of what gravitational acceleration or acceleration of gravity. So it's a type of motion. Random motion is motion of what of body in an advanced or what zigzag manner. So it's a type of motion. So I will go for none of the above. This number 4 say which of the following is the equation of trajectory. Now I would like to express this. Now what is the equation of trajectory? Go and watch my video so that you can get all this theoretical analysis clearer. Now projectile motion is what? Or trajectory what equation is y minus y naught basically equal to what? X tan theta minus what? Gx squared over 2u squared cos square theta. We can also write it as y minus y naught equal to x tan theta minus what? Gx squared over 2u squared. Now cos 1 over cos square theta is what? Sec square theta. And don't forget sec square theta is same thing as 1 plus tan square theta in what? 3 under mathematics. Now in this case now we can say that what? When you're talking about what? If you substitute this one, you would have y minus y naught, y1 minus y naught equal to x tan theta minus what? Gx squared over 2u squared into by 1 plus what? Tan square theta. So any of this formula is correct for trajectory what? Equation. Called a trajectory what? Equation. Now, so which of the option A is not correct? A is not correct because of what? There's no square here. B is not correct because this was going to be at square theta. C, no. D is looking like it. Yes, it's correct. Y equal to x tan theta minus what? Gs square over 2u square 1 plus what? Yes, the answer should be what? D. It is not none of the above. So I've been able to answer question 1 to 4 on that theoretical level question on projectile. If you know you enjoyed the video, please like it and subscribe if you are just seeing my video for the first time. But if you are a returning viewer, thank you for watching and always stay tuned. Thank you. God bless you.